So now it's time to study the conditions which will help the processor decide when to forward the data from the ALU or from the memory phase, or fetch the data from the register file. So assume this is a program, and you can see there is a clearly data dependency here. So the first instruction is writing the data into x2, and then the x2 is being used into second instruction, third and fourth instruction, and the fifth instruction as well. So assume that the initial value of x2 before executing this instruction was 10, but after executing this operation like x1 minus x3, the updated value is supposed to be minus 20. But by the time this instruction is reached to the execution phase, it will not be fetching the updated value of x20 if it would be fetching the data from the register file. So we can actually resolve this hazard with forwarding. But how do we detect when to forward? So if you look at the multi-cycle diagram here, you can see x2, x1, x3 is being calculated, x1 minus x3 is being calculated here. So this value, you see, the previous and the initial value of x2, this is a 10, and in this clock cycle it is also 10, and this clock cycle is also 10. And in this clock cycle, the data is generated, the updated value is generated, but it is not written into x2 until this clock cycle. So here you can see in the first half of the clock cycle it is 10, but after writing, minus 20 is now available. Okay. Okay, so you can see without forwarding, the updated value of x2 cannot be used in the clock in these instructions. Okay, and the updated value is only available in this clock cycle number 5 if we assume that the registers are written in the first half of the clock cycle and read the data in the second half of the clock cycle. If we assume for the time being that this functionality is not available, like functionality of reading and writing the data in different clock cycles within the same within the same clock period, if this functionality is not available, then the correct value of x2 we cannot still use in this instruction. It will only be available for this instruction. So so we can actually solve it with the help of forwarding. But how do we decide, how the processor know whether the data to be fetched from the instruction memory, sorry, the register file, or fetch the data from the ALU, from the execution phase? So we need to study when to forward. So what we do is we actually pass the register numbers along the pipeline. So example, id x, id/x dot register rs1 corresponds to the register number for rs1 sitting in this idx pipeline register. Okay, so if you go back here in this diagram, for example, if the instruction is executed here, okay, and so what we do is we also store the information about the rs1 and rs2 and rd whatever in this register. So idx dot register rs1 corresponds to the rs1 of that instruction. Okay, so back here, so the register operand to ALU in the execution stage are given by idx dot register rs1 and idx dot register rs2. Okay, it corresponds to the instructions rs1 value, which is stored currently in this pipeline register idx. Okay, so if I were to give you an example here, let me pull up the whiteboard. Yeah, so here you can see, for example, if the instruction is, let's say, the instruction executed, let's take the same example, sub x2, let's say it is x1 or x3. So here x2, and this x2 is also used in the next instruction, which is let's say add, let's say it is x6, x2 and x7, for example. So here you can see the data dependency of x2, which is supposed to be written in this instruction, and it is being used here in the next instruction. But by the time this register is written in this write back phase, of course, this instruction might have already fetched the value of x2 from the register. Okay, so it will be fetching the incorrect value. So what we are saying here is this value, which is being calculated at this step, right, this value, this x2 is being calculated here. So what we need to do is, for this instruction here, which is executing in this phase, we need to fetch this value instead from the register file. Here is the rs1, sorry, this is rs1. So instead of fetching the value from rs1 here from this path, what we need to do is to fetch this value from this path, because this contains the updated value. It somewhere go here like this. Okay, so this should be the path to use the updated value of x2. Okay, now what I'm saying here is, so this is for this instruction, the idx, not for this instruction, sorry. So here, because this instruction is in this phase, so what we do is we will check x, mem, and rd. So what is the rd? It's sitting in this register, and the xmem register, it is this x2 equal x2. So the processor will grab the value, this value, and check if, look at this register idx. So idx, id slash x dot, let's say rs1. Okay, if this is also equivalent to x2, here in this case it is x2, when both are equivalent, this one and this is equivalent, it means that the value x2, which is just being updated, it has to be used in the next instruction, and in that case we need to forward the data from this path, from this execution path to here. It could be the data dependency of x2 could also be used in idx dot rs2. So we need to check both of the registers. Okay, so the first condition that we need to check data hazard when xmem register rd is equivalent to idx register rs1, or similarly register rs2. So what we need to do, we need to forward the data from xmem pipeline register and use it in the ALU for the next instruction. Okay, this same as a thing which I have just explained to you on the whiteboard. Here you can see sub x2. So x2 is sitting in this register xmem.register rd, which means that the instruction in this phase, in this stage, has an rd which is x2, and it is exactly equivalent. The same register is used as a source register in the next instruction. So it means that the x2 may not have the updated value. So we need to forward the data. We need to use the data, which is recently updated data, and is stored in this register, in this pipeline register, and we have to use it for the next instruction in the ALU, rather than fetching the value of x2 from the register. Okay, so similarly, so this is the case, this is one condition. Similarly, when this instruction reaches to the next phase, so when it reaches here, so the previous instruction has already used, so this previous instruction has already used the updated data of x2, but when this instruction is in this phase, another instruction is also requiring the updated value of x2. And again, here in this case, the x2 is not updated yet, because the x2, the value of x2 will be updated in the write back phase. So which means that we also have to forward this value. But where do we need to forward the data from? Now, once the sub instruction is moved into this stage, the updated value of x2, which was initially generated from this stage, it was first stored in here when the sub instruction was in this stage. But when sub instruction is moved to the next, in the next clock cycle, sub instruction moved into this stage. Now the updated value of x2 is stored in this register, which means that Now for this dependency, we need to forward the data from the memWrite back phase, because the memWrite register now contains the updated value of x2. Okay, so just know that when the instruction is executed here, when the instruction is executed here, the updated value is stored in this register. When this sub instruction will move to the next stage, everything related to sub instruction will move to the next stage. Okay, so including the control signals, including the value of x2, which is supposed to be written back into the register in the write back phase. So when the instruction moves to the next stage, the value of the updated value of x2 is also moved here. Okay, so in if the instruction is using, just like this one, if the instruction is using here, any of the source register is using the value that is not yet updated in the register, so we need to forward the data now, this time from the memWrite back phase. Okay, because the updated value is placed in this one. Okay, so the second set of condition would be checking the register RD sitting in the mem write back phase and compare it with the values in the IDX register RS1 and the IDX register RS2. Okay, so in that case, if this condition satisfy, we need to forward the data from memWrite back pipeline register, and this is what I have just explained to you. So looking at this diagram, looking at this code, what do you think this data dependency is specified by which instruction? So give it a pause here and ask yourself which instruction will satisfy, which of the condition will satisfy in this particular instruction. All right, so the instruction that satisfy, the condition that satisfy in this instruction, the case of this instruction, it will be this one, because when this instruction is in the xmem phase, the xmem register RD, which is x2, it is the second instruction and will be in the execution phase, so IDX register RS1 corresponds to this condition. What about this one? So which condition satisfy for this one? So here register RS2, IDX register RS2 is equivalent to the memWrite back phase register RD. So this will be the condition which will qualify to forward the data from memWrite back, forward the data of x2 from the memWrite back register for this instruction. What about this one? We do not need forwarding in this case, because by that time the register x2 would be updated into the register file, so it will fetch the correct data of x2 for this instruction and for the next one.